All right, so today I'm going to go over these 4 topics here. So you guys see my screen, correct? Inverse function. Very good. So I'm going to go over these 4 topics, and this will be the end of chapter 2, also chapter 1. And we're going to have exam 1 on chapter 1 and 2. I just post the practice exam 1 online. If you go on Canvas, you will see practice exam 1. So that exercise is not being graded, but it will help you to see how the exam look like. The exam will be similar style. The only thing that I will add it is a time. In this practice exam, you don't see a time counting down. But in the actual exam, you will see like a 75 minutes, 74 minutes, it goes to 0. All right? But everything else will be the same style. You will have 2 attempts for each questions. Any question?
How long will the exam be?
I will give you guys enough time. It depends how many questions I'm going to make, but I usually give you guys 1 or 2 hours. So I give you guys one or let's say around 75 minutes. But 75 minutes, when you start, you should finish it. You cannot pause it, come back tomorrow. But I give you guys few days to take the exam. Similar to the practice exam, I posted today. You will see practice exam till probably next few days. Anytime you start, you have to finish it. Same as exam 1. When you click on it, your time while clicking, you have to finish it. So you need to decide what day and what time on the days that I give you guys is the best for you to take. You have to make sure your internet works, the browser works, everything works. All right, Matthew? All right, guys? So, whatever you want to do, I just want you to take it. I don't want anybody else to take it, because final exam will not be like this. So before I go to these topics, let's go over the homework question that Tamir asked me. Tamir asked, I think he said, there is a function f of x equal to 10 over x squared. All right, Tamir? Probably there's a graph. Yep. The graph probably is something like this. But we don't need if they give us the graph. And they are looking for the range. But they give us the domain. X is between 10 and negative 10. Is this correct?
Yeah.
Are you sure?
Yeah, I'll double check too.
Is that X gonna be, they said X cannot be 0 somewhere, or?
Yeah, that's what the domain was on the homework.
So they said X cannot be 0 as well.
It didn't say that exactly.
Okay, but without this doesn't make sense because we cannot put 0 on the denominator. So what's happening here, in your level, you should be able, when you see this function, you need to see, oh, this is not linear, that's not quadratic, it's not cubic, not exponential. We learned about this function at the chapter 11, which is rational function. But for now, for any function, we know what domain and range is, correct? My handwriting, domain and range. They said domain is between negative 10 to 10. That means the bottom, if this is a number line, 0, negative 10 here, positive 10 over here. Any number you pick there, not 0, you plug here, we're going to have a value of y. For example, if x equal to negative 10, what is y? Y will be 10 over negative 10 squared, correct? With 10 over 100 will be 1 over 10. Good. So if x equal to, for example, if you put negative 1, what do we get? Then y equal to 10 over negative 1 squared, which is 10. So far, if you put negative 10, we get 1 over 10. But if you put negative 1, you get 10. You guys see the graph? So we know range is value of y. So basically, they're asking you, what are the y? I mean, what's the value of y? What's the bottom of the minimum part of the y and maximum y we get? Correct? What's the meaning? That's the meaning of the range. So if you assume this is a factory and all the inputs are between negative 10 to 10, what are the outputs? I plug negative 10, I got 1 over 10. If I put x equal to like 0.2, x equal to 0.2 here, what do you think the value of y will be? The value of y, I mean, we plug it, we start to say y will be 10 over 0.2 squared is 10 over 0.2 squared is 0.04, correct?
Yeah.
What is 10 over 0.04?
250.
Yeah. So when is, if you see the graph, if it's 1, for example, we're going to get 10. If it's 0.2, we're going to get like a 250. So if it's close to 0, we're going to go to positive infinity. So what's the range of this graph? It will go from 1 over 10 to infinity. We're going to say y is going to be greater than equal to 1 over 10. Where is 1 over 10 coming from? 1 over 10 coming from when I plug negative 10 to the function. Does that make sense?
Yeah.
Let me fix my window. Any other homework question? So for question like this, I would like you guys to spend 20 to 45 minutes. You know the definition of a domain, you know what range is. So we trick you guys. I mean, we like to make it a little challenging. So don't give up. Spend 20, 30 minutes and then ask me for help. Any other homework question? All right. So let's talk about inverse function. Function, which is input and output. I'm going to draw my favorite factory. A goes to 5, B goes to 7, C goes to 10. All right, this is domain and this is range. I'm going to call this one F. So F gets input, which is A. A going to go outside, something happening inside, so something cooking inside, the output is 5. We write it F of A equal to 5, correct? The inverse mean some people are interested, some people like to hack the system. They're going to say, for example, so we're going to go this, the other way direction. We're going to go this direction will be F inverse. So F inverse of 5 will be A. So again, this inverse here, you need to have this in your note sheet that F inverse is not equal to 1 over F. Algebraically, when we have a negative exponent, we will flip it. But for the inverse function, that's totally different concept. The inverse function means we have a range, we're going to go inside of the function to see what was the inputs. For example, F inverse of 10, the answer will be, Lindsay going to say it. The answer will be C, correct? 10 is inputs of the inverse. So that means if 10 goes inside of this function, the output will be C. Question? Example, function f is 0.1, 2, 5, 8, 9, 15. So this is a function. My question is, find f inverse. What is f inverse? I guess thinking or what is f inverse?
Do we switch the x and y values?
Very good. So we're gonna change. So f takes 1 to 2, f takes 5 to 8, and 9 to 15. F inverse take 2 to 1, 8 to 5, and 15 to 9. So we just switch x and y, correct? But this is the inverse. Let's have another example. G is a function that takes 5 to 9, 3 to 7, and 8 to 9, and let's say 0 to 2. Is there any problem with this function? Can I call it function? Yes, correct. Say again.
The 9 is in 2 different y values.
But in order, okay, that's a good point. 9, we have 2, 5 goes to 9, also 8 goes to 9. So do you think this is not a function? In order to say is a function or not, we only look at the domain and none of them repeats, correct? So this is a function. But happens that 5 goes to 9 and 8 goes to 9. That's nothing wrong with that. My question is, what is G inverse of this function? The G inverse, we're going to switch. It will be 9, 5, 7, 3, 9, 8, and 2, 0. Agree? I mean, the G takes 5 to 9, but G inverse takes 9 to 5. It inverses. What can I call G inverse? Is that function or is not a function?
Not a function.
Is not a function. Why? Because 9 went to 5 and 9 went to 8. So this is not a function. So if we have a function, it's not necessary that the inverse of that will be a function. For the first example, it was a function and the inverse was a function as well. But the second one, the inverse was not a function. For the first function, they call it 1-to-1. So a function is 1-to-1 if the inverse of that is a function as well, right? That's the only definition of 1-to-1. Any question? Okay. Let's have another example. Function G, we have x and y, 0, 1, 2, 3, 4. It takes us to 5, A, B, C, and 11. What is G inverse of this function?
You switch the x and y values.
Per night, that means 5 goes to 0, A goes to 1, B goes to 2, C goes to 3, 11 goes to 4. I can put x and y as well. Can I say G is 1-to-1? Is that yes or no? Is that 1-to-1? Is that 1-to-1? So the definition of 1-to-1, the G inverse should be a function too. So G inverse, none of them repeat. So this is a function also. The original was a function. So it is yes, is a function. Can you guys tell me what is the domain of G? and what is range of G, also domain of G inverse and range of G inverse. So domain of G, the way I give you guys the function is a table. So pretty simple. Domain will be all the value of X. I'm going to put a 0, 1, 2, 3, 4. The range will be 5, A, B, C, 11, correct? And for the inverse, G inverse will be, domain of G inverse will be this, with 5, A, B, C, and 11. And the range of G inverse will be 0, 1, 2, 3, and 4. What do you guys see here in comment? We see that the domain of G is exactly same as range of G inverse, and range of G equal to domain of G inverse. So this is very important. So I'm going to write it here, that domain of G equal to range of G inverse and range of G equal to domain of G inverse. So this is super important. Then you need to have it in your note sheet. Any question here? Good. So now let's make it a little spicy. I give you guys a graph. This is X, that's Y. My graph will be something like this. We have no idea what the equation of the graph is, but I'm going to call it f of X. And my question is graph f inverse of X. How do we graph that? So they ask us inverse. The definition of inverse was if this is a factory, if 1 goes to 5, the inverse is going to be the other direction, correct? That means if you have X goes to Y, the inverse will be Y and X. We switch X and Y. So if we pick a point here, same as previous example, we had X and Y, we switch them, but they're like an infinite point there. Like if this is 0, 8, the inverse is going to be like 8, 0. So this will be a point on the inverse function. So we cannot just pick a point and then you switch them. What we do, the cheating way is we make a line which is Y equal to X. Correct? So we make a line Y equal to X, and we reflect the graph through that line. Reflected means we're going to connect this one and continue. You're gonna connect it and continue. Connect it and continue. So what's gonna happen? We're gonna have like similar. Something like this. So this will be f inverse of x. So you know the technique. When I give you guys a table, you switch x and y. If I give you guys a graph and ask you guys what is the inverse of this, you don't need to get panic and Google it. I mean, you just make a line y equal to x and then reflect it. One quiz for you guys. This is x, that's y. I give you guys a graph. I call it g of x. Good. So that's given. You know I can bring 100 different questions about the graph, but what I'm going to ask you guys, my question is this one-to-one? Is g of x 1, 2, 1? Is that yes or no?
No.
I don't think so.
All right, the answer is no. Why is no? So this g of x is a function, right? Because it's a vertical line, it makes it a function. But is that one-to-one? That means if the graph of, so if you graph the g inverse, graph of g inverse, in order to graph the g inverse, you need to make y equal to x. For example, somewhere here. And then you reflect it. It might be something like, it's going to be something like that. Good. Now, is the new one, is it a function or not? If you make a vertical line, it crosses at 2 points, right? So this is not a function. That means the inverse is not a function, therefore is not one-to-one. But this is too much work. It's so much work to say yes or no. So what should we do? At the beginning, if I give you guys a graph, you make a horizontal line test. Horizontal line test, if it crosses at 2 points, then is not one-to-one. Correct? Much easier to reflect it and then test the vertical line. So horizontal line test tells you is that one-to-one or not one-to-one. Any questions so far? Now let's make a little spice here. F of x equal to 4x plus 8. All right. My question is, what is f inverse of x? That means there is a factory here. This factory, if 0 goes inside, we get 8. If 1 goes inside, we get 12. If 2 goes inside, we get 16, correct? So we're gonna have like a millions different type of input and output. Now when 8 go inside, I will get 0. This will be F inverse. I'm looking for the inverse. Sorry about that. I will call, that was my boss. I got stressed out. So that was, I'm looking for the inverse. What is the formula for the inverse? So you know what I'm asking. I'm not giving you as a graph. Graph now becomes simple compared with this one. You just reflect it to y equal to x. I don't give you guys a table to just switch x and y. That was super simple as well. Now I'm giving you guys an equation, a relation between input and output, and I'm asking you, what's the formula for output to go to input?
8 plus, is it 8 plus 4x?
8 plus 4x?
Yeah, or yeah, 8 plus 4x.
So 8 plus 4x is same as, so let's try. Good, 8 plus 4x. That means when I put 8 here, I'm supposed to get 0. Do I get 0? Because when 8 go inside, 0 should pop up. And 12 go inside, I should get 1. I don't think your equation works. Good
Would
try.
it be 8x plus 4?
8x. 8x plus 4. Again, if I put 8 here, 8 times 8 is 64 plus 4 is 68. Supposed to get 0.
Oh.
Very good. Good try. But is the, I mean, there should be a logic. If it's a logic for it, then it should be a formula.
Is it x minus 8 over 4?
8 minus x over 4. Benas, that was you said?
8 minus x over 4.
Okay, let's try. So she came up with this formula, 8 minus x over 4. I'm gonna plug 8. You're gonna have 8 minus 8 over 4 is 0 over 4 is 0. That's correct. Now I'm gonna plug 12. You have 8 minus 12 over 16. It will be 8 minus 12 is negative 4. Negative 4 over 16 equal to negative 1 over 4. That's not correct.
Would it be
Is it
x over 4 minus 2?
8 minus 4 over 2.
X over 4 minus 2.
So this is not correct. Good try. So x minus 4, x over 2 minus 4, that's, let me try this one. 8 over 4 minus 2 gives us 2 minus 2 equal to 0. That works. 12 over 4 minus 2 equal to 12 over 4 is 3 minus 2 equal to 1. That works very good. Hopefully last one doesn't work. We have 16 over 4 minus 2 equal to 4 minus 2 equal. So yeah, this looks like working. But I tried 3 numbers. But what's the logic behind it? So in order to find the inverse of the equation, we need to go through a few steps. So there is no negotiation. We don't want to try it. What are the steps? We erase this part. We make room. So those steps should go to your note sheet. And you have a question like this in exam, you will follow the steps. Again, you don't need to Google, you don't need to invite your friends to find the inverse for you. You just follow the note sheets. So in order to find the inverse of any type of equation, the first step, I'm going to put a step 0. You just write y equal to 4x plus 8. So instead of f of x, you put y. So there's nothing complex. Step 1, you switch x and y. You say x equal to 4y plus 8. What did we do? Instead of x, I put y. Instead of y, I put x. So I switch them. Good. Step 2, that's a difficult step. You need to solve for y. So you're solving. When you're solving, that gets complicated. What type of equation we are solving, how we solve it. So this takes time. So we will bring this guy over here. We have x equal to 4, y plus 8. We need to solve for y. Again, solving, your brain should go different stage. So you have to isolate y. We're gonna subtract 8. We have x minus 8 equal to 4y. Good. Then divided by 4. Then y will be x minus 8 over 4. So what Bena said, 8 minus x, but should be x minus 8. So you solve for y. I mean, here you're done. The last step is you shouldn't leave it like this. You cannot leave it like, you cannot box this one. They ask you what is f inverse, correct? I know when you solve for y, you get inverse. The last step is you get rid of this y, just shade it, whatever you like to, and you put f inverse. Good. Or you go here, f inverse will be x minus 8 over 4. Any question?
On a test, would we
Uh-huh.
have to simplify that down to like x over
What,
4 minus
no,
2?
what you did was good too, but you don't need to.
Oh, you don't need to do that?
No.
Okay.
This is same as x over 4 minus 8 over 4, which is exactly this one, what Lindsay said.
Okay.
All right, so you see the level of difficulty from giving you guys a table or giving you guys a graph or giving you guys an equation asking for the inverse. So in your note sheet, you need to emphasize, I mean, if I give you an equation, you need to pay more attention. Let's have one more question. F of x equal to, let's pick a good one. Three x over 2x plus 1. All right, this is great. Sunny day. I give you guys a function. The function happens to be rational. Nobody likes a rational function. It's complicated. It is difficult to graph, difficult to analyze. My question is, what do you think I'm going to ask you guys? Is that sunny or rainy? No, it's not. The question is, what is the domain of f? And what is the range of f? Can you guys do this for me? What's the domain? What's the, what's the domain, Benaz?
I haven't figured it out yet.
All right, who'd figure out the domain? For the domain in your note sheet, we should have a technique to find the domain. On last week, we went through different type of functions. We learned that if we have a rational function like this, correct? The way we write the domain will be all real number minus set of number that makes the denominator 0. So we're going to say we can plug any number to that function, not negative 1/2. Where is negative 1/2 coming from? Negative 1/2 coming from the denominator. If you make the 2x plus 1 equal to 0, you're going to have 2x equal to negative 1, x equal to negative 1/2. That means if I plug negative 1/2 on for the x, you get 0 on denominator, and 0 on the denominator means the function will break. All right. So what we're going to say, domain of f is all real number minus negative 1/2. Let's say you came up with this formula and you're going to sell it on Amazon. So you need to tell your customers what number to plug in. You don't want to get sued. You don't want somebody to come after you. So you're going to say you're selling this function to everybody, or everybody can plug number from negative infinity to positive infinity, but not negative 1/2. Correct? Negative 1/2 should not be one of the inputs. Then you're sure you can just sell it. Nobody's going to sue you. That's the meaning of the domain. That means any input we're going to get, not negative 1/2. Does that make sense? Hopefully. What's the range of this function? Lindsay? What's the range?
Is the range x is equal to 3/2? or all real in interval notation x is greater than or equal to 3/2?
Y greater than 3/2?
No, just equal to y equals to 3/2.
No, range, no. Good try. I mean, when we graph, for example, let's say we graphed the function, the graph was something like this. Good. So we are talking about the value of y. Those are the range. Finding the range is not simple. In most of the exercises, as you see on the homework, they ask you to find the domain. But when they ask you guys to find the range, that means you should be able to do it. What's the technique to find the range? Technique is on here. They said domain of a range of G or a range of a function equal to domain of inverse. Again, for the domain, we have techniques to follow. For the range, there is no techniques. I mean, you can graph it and then look at the value of y, which is, you need to have a great graphing calculator. But in order to find the range, we need to find f inverse of x. And then we find the domain of f inverse, which will be range of f. Good? I know you guys didn't, at the beginning, you were happy that I'm asking you guys find the inverse. But in order to find the range, you need to find the inverse. So let's do it. What are the steps to find the inverse? Step 0, we just switch x and y, correct? No, we just write y equal to 3x over 2x plus 1. Just love it. Don't freak out. Don't think this is too much. No. That's a technique that if you get your PhD, people use it. In your level, you will use it, and I will use it. Those are the steps to find the inverse. Then I switch x and y. X equal to 3y over 2y plus 1. Another step. Second step. We don't freak out. I mean, just we switch x and y. You have those techniques written in your note sheet, so you go step by step. What's the step 2 that you guys don't like? We have to solve for y. The word solve is not something simple. So you need to do your best to don't have any algebraic mistake and solve for y. I see some of you guys don't have camera on. Please make sure you have camera. I mean, you need it for final. But... So we're going to solve for y. There's a y here. There's a y there. So definitely we need to collect them, combine them, factor them. I cross multiply. I'm going to have x 2y plus 1 equal to 3y. I distribute this one. We get 2xy plus x equal to 3y. From here, we have 2xy minus 3y equal to negative x. I moved 3y over here by subtracting from both sides. I moved x over there by subtracting x. I will factor the y. I get 2x minus 3 equal to negative x. Now I don't have room. I divided by 2x minus 3, 2x minus 3. We get something that Lindsay got. So f inverse, so we find the inverse. F inverse of x become negative x over 2x minus 3. What is the domain of this function? Again, you're going to find the domain in your note sheet. There are bullet point. How do you find the domain? If it's a rational function, you're going to have r, real number, minus whatever makes the denominator 0, which is 3/2. So that's the range. Lindsay, do you see that? I can tell that you did find the inverse. Very good. When you find the inverse, just do the domain. Domain, the denominator cannot be 0.
Okay.
Very nice, very nice. So you see the level of difficulty. I mean, it gets not difficult. I mean, it will get difficult compared with the example that I make earlier. You guys want another one, spicy? Why not? Well, we're still in inverse function.
Can you do one more?
Should we do one more? I will change the question to example. F of x equal to 5x. They're asking us evaluate f of 4 and f inverse of 15. So let's go over this one. F of x is 5x. Evaluate f of 4. I know you guys love this one. So f of 4 will be 5 times 4 equal to 20. You're done. All right. Now the second part is f inverse of 15. Do we have a function for f inverse? No, correct? If we had f, we just plug it in. If we had the f inverse function, then we will plug 15 for x. But because we don't have it, you need to go through the steps to find f inverse. So y equal to 5x, x equal to 5y, then y equal to x over 5. I solve for y. Then I cross y. I will put it f inverse of x equal to x over 5. They ask us what is f inverse of 15. It will be 15 over 5 equal to 3. All right. Concavity here, something that you will deal with it on calculus course, but you should know, if I give you guys a graph, if the graph is concave up, usually it's concave up or concave down. Example, is this concave up, concave? Which one do you pick?
Concave up.
Very good question, yeah. Concave up, correct. This is goes up, concave up. Let's have another one. Is this concave up or down?
Down.
Very good. This goes down. Let's have another one. Is this concave up or down? So example 1, I know you guys love it. Example 2, you will love it more. But I'm not going to ask you, I mean, you know it. Obviously, concave down, concave up. What you're going to see in example, in the homework, they give you a piece of the graph, little bit, that is not like this, obvious, that goes up. But the question is this goes up or down?
Up.
This goes up. What about no, this goes up or down? So is concave up if is increasing, and concave down if is decreasing. So in my example, this is decreasing, it will be concave down. Is this concave up or down? Differently, we cannot say, correct? So what we do, we gotta break it down to this interval. So this interval, we're gonna say concave down, then we have concave down, then we have concave up and concave down. So we break it down. In this example that I made, this is concave up. This is decreasing. This is decreasing, but it's concave up. Let me have another example. What about this one?
Concave down.
Concave, is that increasing or decreasing?
Decreasing.
Decreasing and concave down. Very good. Composite functions. Let's say we have a function here. Okay, this is a review from algebra. 5 goes inside, we have 10. 6 goes inside, we have 12. 7, we have 14. And somebody else, and there's another factory here, for example. This factory, 10 goes inside, we get 100. 12 goes inside, 144. And I have no idea what 14. I think it's 196. And 14 goes, we get 196. Is that 14 is squared 196? Is that correct?
Yeah.
Good. So what's happening here? Let's say this is F and this is G. The output of F went inside of input of G. And we got the output, another one. So, and we might have another function here, for example, this output gonna go to this function, and this output gonna be input of H, and we have output. So nothing is wrong. I mean, they're separately functioned. They have nothing to do each other. They're like a different, correct? But one of the output will be input of another function. And we call them, we are composing them like a f of g of x or g of f of x. In our example was g of f of x. The output of f of x was input of g. You just try to understand this picture. Don't worry about this one. How do we write composite function? We write f o g. This is same as f of g of x. That O doesn't mean multiplication. That means just composing. All right, let's have a couple examples. F of x equal to 5x plus 8 and g of x equal to x squared. All right. So we have f is linear, g is quadratic. This has their own factory, and this guy has their own factory. My question is, what is f of 0? What is g of 1? What is f of g of 2? Or what is g of f of 0? So f of 0, that means we only deal with the first function. There's nothing to do with the g. X here, x there, we're gonna have 5 times 0 plus 8. The answer will be 8. G of 1, we are dealing with this function, is 1 squared is 1. So this is done. The other one is done. Now they're asking us f parenthesis g of 2. So we are dealing with two functions. This is exactly same as f o g of 2. If you see a question like this, you need to make it to this form. It's much easier to follow. So again, your book might write it this way, or FOG parenthesis 2. Good. You need to rewrite that. That doesn't mean FOG multiplied by 2. That means this 2 gonna go inside of X of G, and the answer gonna be inside of X of F. But in the parenthesis, if you write it like this, so G of 2, you go to the function G, you evaluate G of 2, which is 2 squared equal to 4. You get this one, somehow you bring it back to the parenthesis. Now you need to find f of 4. F of 4 will be 5 times 4 plus 8, which is 28. Like it. Don't dislike this question. This is like a foundation of this course. Only practice. What is g of f of 0? Again, the parenthesis f of 0. You will look at the f of x, which is here, 5 times. So f of 0 will be 5 times 0 plus 8. The answer is 8. Then g of 8 will be 64. Any question? Okay, let's have some spicy before you go to your home, or you are at home, you go outside the home. The question is, f of x equal to x squared plus 1. G of x equal to 2x plus 3. Correct? This is, I give you guys this information, this two functions. Now what I'm going to ask you guys, we're going to ask you guys find the inverse. Is that 1 to 1? What's the domain? What's the range? No, I'm not going to ask you guys that. I'm going to ask you guys, what is f of g of 0? What is g of 1? I know you guys don't like g of g. I mean, we also can put output of a function as an input. And what is f of g of x? And what is g of x? So when you look at the question, you need to differentiate it. By end of the course, you're going to learn so many different topics. This one, we are composing two different functions. F of g of 0, inside of the parenthesis, g of 0, the answer is, you use this function. G of 0 will be 2 times 0 plus 3, which is 3. So therefore, we are looking for f of 3. F of 3 will be 3 squared plus 1, 9 plus 1 equal to 10. Done. What is g of 1? You cannot say, oh, that's not possible. No, this is algebra. We abstract g of 1. We are able to get it from here. And g of 1 going to be 5. Okay. G of 1 will be 2 times 1 plus 3 equal to 5. So now what is g of 5? it will be 2 times 5 plus 3 equal to 13. I know you guys are tired, but we're almost done. Any question? So what is f of g of x? Now we are dealing with x here. For the number, so for example, for the previous two questions, we actually evaluate the number, we plugged it back, it was not bad. But now they're asking us, what is f of g of x? So this g of x is this guy, 2x plus 3. So basically, they're asking us, what is f of not easy to read, 2x plus 3. Right? Instead of g of x, I plug 2x plus 3 because g of x equal to 2x plus 3. What is f of 2x plus 3? F of x was equal to x squared plus 1. So whatever is this, if this is like anything, you got to plug it there as well. Good. So it's going to be parenthesis 2x plus 3 squared plus 1. So this is the final answer. You can leave it as factor form, or you can leave it as, you can simplify it. You can simplify the parenthesis. But this is what we like. Do you see what's happening here? I plug the entire function inside of the x of f of x.
I have a question.
Yes, Lindsay.
Don't you plug that into that equation? So, for example, it says gx. Don't you plug 2x plus 3 into 2x plus 3? So it'd be 2 times 2x plus 3 plus 3?
For the next one, for the g of x, we do. For this question, they said f of g of x.
Oh, okay.
Right?
All
You're
right.
one step ahead of us. So here, for the last part question is g of x, g of x. So again, we don't freak out. We follow the logic. G of x is 2x plus 3. What is g of that? So this will be inside of this x will be 2 parenthesis 2x plus 3 plus 3, which gives us 4x plus 6 plus 3 is 4x plus 9. All right. I will make a video for the horizontal and vertical shifts, but it seems like you guys didn't like the last part. Then we have one example, then I really let you guys go. H of x equal to x squared, f of x equal to 3x plus 5. What is h of f of x, and what is f of h of x? When you see a question like this, you know that we are dealing with two different functions. One of the output will be input of the other one, correct? We know that concept. So this f of x here should go to the x of h of x. So h of 3x plus 5. Instead of f of x, I put 3x plus 5 because f of x equal to 3x plus 5. H of x makes it x squared. If it's 3x plus 5, it will be 3x plus 5 squared. For the last part, f of h of x, gonna have f of x squared equal to, so this is f, the function f, if you put anything here, if it's a house, it makes it to 3 house plus 5, correct? So now it's x squared, gonna be 3x squared plus 5. All right. Probably was too much, but I will add some videos and more example. Go over the review exam 1. There are a lot of homework for chapter 2. Let me know if you have any question. Add your question on the discussion room on the Canvas. Hopefully somebody will answer it or I will answer it. I will email you guys when I post the exam 1 up. Okay? I give you guys 2 or 3 days to complete 75 minutes. So I give you guys 3 days to take it.
Are we able to use our notes on the test?
How can I say no? Yeah, you can use it. I mean, I cannot. I really like you guys have a very smart note sheet that you, whatever video you're watching, I mean, whatever, I mean, you take a note in your homework, you organize it and use it for the exam. That's the best way to take the exam. It's not enough time to Google it. It's not enough time to call a friend. It's not enough time to just open the book. It's enough time to read your notes to solve it. Yeah, you can have a note, as many pages you want. I would suggest only 1 page because it's easy to navigate to that particular topic. It's not challenging. Please do not hire or invite your friends to take it. Any other question? David, do you have a question? No. Ella? Any question? All right, guys, see you guys tomorrow. And hopefully tomorrow I will tell you guys about exam more. I will start chapter 3 tomorrow. All right. Sure. Have a great day.
Thank you.
All right, guys.